In this video, we'll discuss making a decision about the two-factor analysis of variance. How do we decide if there's significance? How do we decide if we reject that null hypothesis? We will also take a look at SPSS output so that you are able to interpret what that SPSS table means. And then we'll discuss how we would report the two-factor analysis of variance in the literature. So here's a table that you might find if you were doing the analysis on your own, how you would put all that data together and sort through it. So it looks somewhat similar to the one-way analysis of variance table. And here the things that we're interested in is factor A. We have our degrees of freedom, we have our MS value, and we have an F value. For factor B, we have our degrees of freedom, we have our MS value, and we have an F value. And for our interaction, we have our degrees of freedom, we have an MS value, and we have our F value. So these would be our calculated F values. These are the degrees of freedom that get reported. So we report the degrees of freedom for that factor and the degrees of freedom for the error term. Degrees of freedom for that factor and degrees of freedom for the error term. Degrees of freedom for the interaction and degrees of freedom for the error term. So we also need to find our critical value. So to do that, we need our degrees of freedom, and we will go to our F distribution table. And we have, in the numerator, our degrees of freedom is 1 for all three, and it's 76 for all three. Now, if you go to the table, you'll see that there's a value for 70 and a value for 80, and our error term, degrees of freedom, is in between that. So we'll use a smaller value to be more conservative. So we go with the degrees of freedom for 1 and 70, and if we look at that in the table, that will give us a 3.88. So what is significant? If we compare this F value, our calculated F value, to our critical value, this is bigger, it's out there in that critical region, so the main effect of A is significant, which means we reject the null. If we compare this F value for factor B to the critical F value, the main effect of B is also so we also reject the null. And then for our interaction, we're going to compare this calculated F value to this critical F value, and it's also out there in that critical region, so it is also significant, which means we reject the null. So if we were to write this in the literature, we could write the analysis of variance indicated significant in effect for factor A. And most likely you know what the name of the condition was. Here we're just calling it factor A. So then you want to write your F statistic with your degrees of freedom. Just say it's 4.0, and was at a P of less than 0.05. Just in case anyone looked, actually this number is off. It is 3.98. 4 degrees of freedom of 1 and 70, and an alpha of 0.05. And then the same would go for the other ones. You would just, the ANOVA indicated a significant main effect for factor B, same degrees of freedom, but here you would put 9, and it's P less than 0.05. And same thing for the interaction, except for you would say a significant interaction. So this is what an SPSS output might look like for a factorial design. So here we have our main effect of A, our main effect of B, and our interaction. here's that error term for degrees of freedom. So if we were to write this out for field of study, which is our factor A, we would write out F, our degrees of freedom of 1 and 16. Our F value was 1 equals 0.174. Our P value, so now we know the exact P value, so we report that. For factor A proximity, same degrees of freedom. Now our F value is 5.84 with a lowercase p equal to 0.028. 5.84, 0.028. And then our A by B interaction, .063, P equals 0.039. So these are both less than 0.05, you see, but not that much less. But because we know the exact value from SPSS, we report it. And this is what that interaction looks like. So for this study, this was proximity to the exam for business and psychology majors. So this is saying for psychology majors, it doesn't matter how close to the exam it is. They have the same level of stress. However, for business majors, proximity to the test makes a huge difference in their level of stress, which is much higher when you get closer to the test and much lower when you're farther away from the test.